Hello, welcome. So we're going to talk about piecewise functions today for this lesson. This is kind of our second lesson after, or third lesson after a definition of a function and graphs of functions. And so what piecewise functions are basically functions that are defined by multiple rules, and you just have different domains for each of those rules. So that's really all there is to a piecewise function, is it's got more than one rule. So we've actually already seen an example of a piecewise function, and that was the function absolute value of x. So f of x equals absolute x had a piecewise definition, and we're going to see this a lot in this lesson. And you have these squiggly braces, and these squiggly braces you use to separate out the rules. So the first rule was multiply it by -1 if the inputs are less than 0. And then the second rule was just give me the value back if the inputs were more than or equal to 0. So that was an example of a piecewise function. There's two pieces: what you do when you're less than 0 and what you do when you're 0 or more. Okay? All right. So let's look at some examples and try to define piecewise a little bit better. Okay, so a piecewise function is a single function. It's one function, but it has different rules for different domains. I mean, the rules could be the same, but it's got multiple rules for distinct domains. And it's important that each domain is distinct. Distinct meaning they don't overlap. You don't have overlapping domains, because then you wouldn't have a function anymore, because you wouldn't know what answer, which rule to use. Okay, so all the domains have to be distinct from each other. They don't share numbers. Okay, so we talked about absolute value of x, and it has a piecewise representation, or a piecewise definition, which is given over here. If you've got a negative input, this is the confusing thing, I think, about the notation, is that you look over here for what to do. So you look over here and you say, okay, if my numbers inside, if my numbers that I'm plugging in are less than 0, so this is referring to the inputs. If those are negative, then we want to multiply it by -1. And then this is if the inputs, the numbers we're plugging in, are 0 or more, positive or 0, then just give me the answer back. And this is the graph that you'll get when you graph those numbers, right? Like, for example, if you were to plug in 1, then your answer is 1. And if you were to plug in -1, your answer is again 1. And so that's what you get. It looks like x over here. So, oops. It looks like x over here, and it looks like -x, that graph over there. Okay? All right. So the notation for a piecewise function looks like this. You've got a list of rules, and you can have as many rules with domains as you want, as long as each of the domains is distinct. And so you've got f of x equals something with x, and over some domain, rule 2 over some other domain, rule 3 over another domain, and each of those domains need to be distinct. So these are all distinct from each other. They don't overlap. Okay? And that's pretty much it. A lot of students will confuse this domain with the rule. Remember, the rule is how you get the answer. The domain is saying which numbers, which rule should I use? So try not to confuse those two. The domain is always after the rule. Okay? So it always comes afterwards. So we'll look at an example in a moment. This would be a piecewise function. And if we take a look, it's broken into two pieces, right? We've got graph, we've got a function, whoops, so 0, 1, and we're 1 for all of our inputs that are negative. and then there's an open circle up here. We're going to talk more about these open circles and closed circles. And then we're, did I say 1? I meant -1. We're -1 for any negative input. And then up here, we are 1 for any positive input, okay? And so this is the graph of -1 when x is less than or equal to 0, +1 when x is greater than 0, okay? So you can think of this comma as like saying when. So this is when. That's what the comma means. You would say the function is -1 when x is less than 0, less than or equal to 0. And the function is 1 when x is greater than 0. Okay? All right. So let's try to evaluate some stuff. So how do you evaluate piecewise functions? So to evaluate a piecewise function, you determine which domain you're looking at. So you have an x, you have an input, you want to find the answer. So you determine which domain this x falls into. Then you're going to use the corresponding rule. So whatever rule is to the left of that domain, that's what you're going to use. So here's an example piecewise function. We have f of x equals x squared minus 3 when x is less than 0. And so that's a quadratic for inputs that are left of 0, or excuse me, left of 1, sorry. And 2x plus 1, which is a linear function, when x is more than or equal to 0, greater than or equal to 0. So let's try to evaluate this function at those inputs, 0, 1, and 2. So the question is, which rule do we want to use for 0? Which rule do we want to use for 1? And which rule do we want to use for 2? Okay? So, since we're going to try to do the first one, so we're going to evaluate f of 0 first. Okay, so 0 is less than 1. That means it's in the first domain, right? Our number 0 is less than 1. It's not more than or equal to 1, it's less than 1. And so we're going to use the first rule. So we plug 0 into that first rule, and we evaluate it. So f of 0 says we're going to square 0, take away 3, and so that gets us -3. So we use the first rule because our number 0 is in the first domain. Now let's evaluate f of 1. So we're going to evaluate f of 1. So is 1 in the first domain? Is it in the first domain, or is it in the second domain? Well, 1 is not less than 1. 1 is greater than or equal to 1. And so since 1 is greater than or equal to 1, we use the second rule. So we're gonna use the second rule now. Okay? So we're gonna plug 1 into that function. And when we plug 1 into this rule, we multiply it by 2 and add 1. So that's the linear equation that we're using now. And that's going to get us 3 as the answer. Okay? So that's us using the second rule because we're in the second domain. And now let's try to evaluate f of 2. So f of 2, what is that going to be? Well, is it in the first domain or the second domain? 2 is not less than 1. It is greater than or equal to 1. So 2 is greater than or equal to 1. So that means we're also going to use the second rule. Again, just like we did for the f of 1. And we plug 2 into that linear equation, and that's going to give us 5 as the answer. So we could make a table if we were interested in. We could start to sketch the graph out, but our table would look like this. You know, here's our x's, here's our f of x's, and when we plug 0 in, we get -3. When we plug 1 in, that gives us 3, and when we plug 2 in, that gives us 5, okay? So you could make a table, and you can draw a graph from this, okay? All right, let's look at the next example. So graphing piecewise functions, down to the bottom. Okay, so how could you graph a piecewise function? Well, you graph each rule over its specified domain. So whatever domain you're specifying for that rule, that's the function you'll graph. tricky stuff happens at the endpoints. If the x is included, if the number is included, so that's a less than or equal to or greater than or equal to, so that's what I mean by included. This is, whoops, gotta move myself. Whoop. Okay. If this is a less than or equal to or greater than or equal to, then you're going to use a closed circle at that point. If it's not included, that'd be a less than strictly or greater than strictly, then you're going to use an open circle. And then if the point is on both graphs, so it turns out that it's on both of them, meaning the graphs are going to meet, they'll collide at that point, then you don't use the circle at all, you just connect the graphs together. Okay, so you don't need to use an open or closed circle when they meet up. So let's look at an example. Okay, so this is the same graph we were looking at earlier. F of x is x squared minus 3 when x is less than 1. And it's 2x plus 1 when x is greater than or equal to 1. So we're going to graph the first function, which is a quadratic. So let's go ahead and sketch that one out. So for the values that are less than 1, up to and almost 1, we're going to graph x squared minus 3. So let's do some numbers here. We plug 0 in, we get negative 3. So that's down here. And then when we plug negative 1 in, we're going to get negative 2. So that's right there. And when we plug negative 2 in, that's going to give us 1. So that's up here. And so this is part of the graph. Point go there. And now the question is, what should we do at 1? What should we do at 1 for this? There's part of our parabola. Well, if we're going to get really close to 1, but on the left. So to find out what values those are going to be, we're just going to plug 1 in. We're just going to plug it into the first rule and see what we get. When we plug 1 in, we're going to get minus 2. And so as we get closer and closer to 1, we're going to get closer and closer to minus 2. But we'll just use an open circle there because it doesn't include that point. Okay? So that's the green part. That's the first rule has been graphed. So everything less than 1 is part of that parabola x squared minus 3. And so we need to know, again, what's happening really close to 1 but smaller than it. Well, it's still that parabola x squared minus 3. So that's what we're graphing. Now let's graph the second part of this. Oops, I'm going to move myself back up here. All right, so the second part, 2x plus 1, that's a linear equation that's got a slope of 2 and a y-intercept of 1. So if we were to plug 1 into this, that gets us 3 as our answer. So here we are up at 3. Let's keep using green because it is, after all, one function. So we're up at 3. So we're going to plug, when we plug 1 in, we get 3 as our answer. And since it's a or equal to, we use a closed circle. Okay? So this is the closed circle one. This is the closed circle. Closed circle. And then this one up here is the open circle because it's not or equal to. That's what I mean by the if it's included, use an open circle. Or if it's included, use a closed circle. If it's not included, use an open circle. And then we continue graphing 2x plus 1. So it's got a slope of 2. So we're going to go up 2. And that's going to be our graph, just like that. So there's our graph. You can see that 1, negative 2 has an open circle there, right here. And 1, 3 has a closed circle right there, which says that when we plug 1 in, we're going to get 3 as our answer, which makes sense because 1 is in the second domain. And so we should use the second rule. And then there's 2x plus 1, and then this is the x squared minus 3 graph. Okay, so now you try on a piece of graph paper, try graphing this piecewise function, negative x plus 1, when x is less than 0, and x squared plus 1 when x is greater than equal to 0. So our domains are split at 0. So everything left of 0 is going to be the first graph, first function. Everything right of 0 is going to be the second function, and 0 as well, because it's or equal to. So I'll pause the video and then try to graph this one, and then you can check your work in a minute. All right, let's review the answer. So the first function, negative x plus 1, that's just a linear equation with a slope of negative 1 and a y-intercept of 1. So let's go ahead and we'll just kind of mark this green part. This is negative x plus 1, and you can see its slope is negative 1. And as you get closer and closer to 0, you're going to get closer and closer to 1 as your answer. And then the other graph, x squared plus 1. So we can mark this with red. This is x squared plus 1 over here. So that's the other rule. And we start graphing that at 0 going on. So when we plug 0 in, we get that number 1 as our answer. Now, since those two graphs are colliding, they're going to the same value, the same answer at 0, there's no circle. There's no open circle, there's no closed circle. You just connect the graphs together, just like that. So we have our parabola that goes that starts at 0 and goes to the right. And then we have our linear equation that's just to the left of 0 going to the left. Okay? All right, let's try another one. Okay, let's do another problem. Oops, don't want to see the answer just yet. So on a piece of graph paper, try graphing this piecewise function, negative x squared plus 1 when x is less than or equal to 1, and square root of x minus 1 when x is more than 1. And if you're having a hard time graphing these, try just plugging numbers in, plugging in points, plugging in x's, and seeing what the answers are. And those should help, okay? You will want to plug 1 in to both rules to figure out what those, you know, whether you need to put a closed circle or an open circle there, okay? So for sure, you're going to need to plug 1 into both. And then other than that, you can just sketch the graphs after that. So go ahead and pause the video, and then when you're done, resume it and see if your answer is the same as mine. Okay, let's look at the answer. So there's our graph for negative x squared plus 1 when x is less than or equal to 1, and square root of x minus 1 when x is greater than 1. So I'll have you note that they actually meet, they collide at the same value, 1, 0. And so there is no open circle, there's no closed circle. They're going to meet up right at that value. So let's just see why that's the case. So if you were to plug 1 in to the first equation, so negative 1 squared, negative times 1 squared, negative 1 times 1 squared plus 1. And that's going to give you negative 1 plus 1, which is 0. And if you plug it into the other equation, root 1 minus 1, you get root 0, which is also 0. So they're going to that same value, 1, 0, that same point. So that's why they meet up right there. And then you're graphing the first function, negative x squared plus 1. You're going to graph this guy over to the left. So that's just a parabola that's turned upside down, shifted up 1. So its vertex is at 0, 1. And it's going down. So if you had trouble graphing that, I suggest plugging in numbers, and you can do that just by, you know, what are the values, x, and then negative x squared plus 1. You know, what are the answers? And if you plug 0 in, you get 1. If you plug minus 1 in, you get 0. If you plug in minus 2, that gets you negative 3, etc., etc. Okay, so you should be able to plot that. And then over on the right, we have root x minus 1. So this graph, this is over here, square root of x minus 1. And so that's the square root function, but you'll note that it's been moved right 1. So you can also do the same strategy of plugging numbers in. So if you were to plug numbers in, here's x's, root x minus 1. Some nice numbers are, you can plug 1 in, that gets you 0. Whoops. If you plug in 2, that's going to 0. You're going to get the square root of 2 minus 1, which is 1. If you were to plug 5 in, you're going to get root 5 minus 1, which is 2, root 4, and so forth. So you can plug those points, and you can see them on the graph over here. You know, here's 2, 1 right there, and here's 5, 1 or 5, 2 right over there. Okay, let's try another one. Last one. So on a piece of graph paper, try graphing this piecewise function, negative x squared plus 1, when x is less than or equal to 2, and square root of x minus 1 when x is greater than 2. So you might have noticed that those are actually the same rules. So the only thing different about this one is the domains for each rule. So go ahead and pause the video now and then give this a try. The domains are different, so you're going to get a relatively different picture than what you did, but the functions will be the same functions. You're just going to see different pieces of them. All right, so when you're done trying this, go ahead and replay the video. Okay, let's look at the answer. So that's our answer now. Now you should see we've got a closed circle for the first one. So let's look at the first one. We have a closed circle here. Closed circle. Because it's the or equal to, right? So when we plug 2 in, we want to use the first rule, which is that parabola. So we're going to use the first rule when we plug 2 in. So that's why we've got this closed circle down here, right? So there's our closed circle. Okay, and then we're going to have an open circle for the other one. So this one's an open circle. This is an open circle right up here. So that's what's going on up here. Let me see if I can. So there's our open circle right there. Okay, and so to find these points, you plug 2 into both of the equations. So for the first one, when we plug 2 in, that gives us f of 2 is equal to negative, excuse me, let's not use our function notation because f of 2, you're always using the first rule. So let's just evaluate. What is negative 2 squared plus 1? So negative times 2 squared plus 1. Negative 1 times 2 squared plus 1. This is negative 4 plus 1, which is negative 3. So that's why we have this point down here at 2, negative 3. And then the other one, root of 2 minus 1, what is that? So that's root of 2 minus 1, and that's root 1, which is equal to 1. So that is our open circle is at 2, 1. So that's why that's right there. Okay, so that's at 2, 1. We have our closed circle down here at 2, negative 3. And then you just graph negative x squared plus 1 to the left, and you graph root x minus 1 to the right. So we've got root x minus 1 is over here, and we've got negative x squared plus 1 is over here. And again, if you're having trouble finding points to plot, you just plug those numbers in and evaluate, okay? You evaluate the function at different x's. All right, so that's piecewise functions. We're going to get some practice with it in class tomorrow. So if you have questions tomorrow, you can always ask them in the YouTube comment section or in the discussion place on Schoology. And then we'll also get a chance to actually do some stuff with piecewise functions tomorrow in class. So again, hopefully you learned something, and I'll see you guys tomorrow.